Now, what is an accelerating admixture? What does the term accelerating mean? Accelerating means you are accelerating some process. You are actually increasing the rate of certain processes. That is accelerating. And what is the process that we are actually increasing? Now, this comes under type C that I discussed the last time from the ASTM classification of admixtures. It comes under type C. It's an early strength achieving admixture. Now, what is an early strength achieving admixture? You are trying to achieve the strength early So I was saying that there is an accelerating admixture. It comes under type C, early strength achieving admixture under this classification. Now, early strength achieving admixture would mean you are trying to achieve the strength early. Now, what are the situations in which we want to achieve the strength early? There are certain applications of such type of admixtures. Now, for example, you want to remove the formwork quickly. In such situations, the early strength admixture could be used where we want to achieve, we want to remove the formwork early. Now, accelerating admixture is actually accelerating the process of not only the strength, but also the hardening of concrete. So it will also accelerate the hardening of concrete, and it will also accelerate the setting of concrete. So there is a certain distinction between hardening and setting. That is, when you have an admixture which is aiding in quick setting as well, that would mean it is accelerating the setting processes as well. So this naturally happens when you want to achieve early strength. The setting and the hardening would also be early. Now, in such types of admixtures, you have the freezing. You are also applying it at in situations where there is a cold weather, which I was discussing the last time, where the temperatures are decreasing below freezing point. You're using in those situations, and that would mean now when you are using it below freezing point as well, at least it is decreasing. It is not actually, it is decreasing the freezing point of the concrete by around 2 degrees Celsius. So you are not actually using it below freezing point, but it's decreasing the freezing point by around 2 degrees Celsius. So thereby the concrete is not freezing. And what I was discussing last time, when you have concrete, there is water particles which are getting trapped in between, and these particles, and they get frozen if it's a cold weather. So that will not be available for hydration. So the hydration processes will not happen within the designated 10 hours. So the setting will be affected, and overall, then there will be crumbling of the particles that will start, and there will be cracks. So there will be then honeycombing action as well. So in such situations, you require an early strengthening compound, which is actually setting quickly, strengthening quickly, such that it does not freeze before. Now, how does the strength increase? What are the different types of admixtures that which are accelerating? Calcium chloride is one. Now, calcium chloride comes with a combination of C. When it's combining with C3S, what happens is that there is a change in the alkalinity of the pore water, and thereby calcium chloride is actually increasing the strength, but at the same time it's also leading to drying shrinkage of the concrete. And also calcium chloride, because it's a salt, it's also aiding in corrosion of steel if it's embedded within the concrete. So it has got a positive effect that it's changing the alkalinity of the pore water, thereby it's when combining with C3S, and thereby it's aiding in early strength development. But at the same time it's also leading to drying shrinkage, जिसकी वजह से shrinkage cracks इसमें हो जाती है. So and it's also aiding in the corrosion of steel. It's increasing the creep and freezing thawing cycles of the later age concrete. So during the freezing thawing cycles, if for example you have, it increases the creep first of all, which is the age related phenomena of deflection of concrete happening. So creep is a strain that happens due to fatigue, due to aging. So it increases that process once you are using the calcium chloride as an admixture, as an accelerator. And it also increases the effect of freezing thawing, that is पहले froze हुआ, फिर then it defreezes, then again freezing and thawing. तो ये cycles इनका effect होता है on concrete, इस deterioration of concrete हो जाती है इन cycles की वजह से, and it's actually increasing that effect. So it's a bad thing in regard to that, but it's offering resistance to erosion and abrasion of concrete. So on this point, it's good. It's a good thing that it is a resistant material. It's offering, once combined with calcium chloride, concrete is offering more resistance to erosion and to abrasion of concrete. Now, there are other compounds as well, like calcium nitrate or nitrites, calcium nitrites. They also aid in acceleration of the strength development. Of concrete. So you can use these compounds in the as accelerators. You can also use calcium ferrates and sodium ferrates as accelerators. So calcium chloride is the most prominent one that's used, but these are also used. Now these calcium ferrates and sodium ferrates are effective when you have more content of C3A in cement. So these are effective with respect to that. Then there are certain triethyl no ethanol amine. This is a compound. This is also used as an accelerating admixture. So these are all chemicals that you are using, or the salts that you are using as accelerated admixtures or early strength achieving admixtures. So what does an accelerator actually do? It is actually increasing the early strength development. That is, the process would be like this. If this is time, and if this is strength, the process would be like this. If this was without accelerating admixture, this would be with accelerating admixture. But the overall strength would be almost same in both the cases. It's only that this achieves strength earlier. This is with admixture, accelerating admixture with, and this graph, the low one, overall strength that is achieved is almost the same in both the cases. This was about the accelerating admixture. Anything you want to ask? Anyone?
Sir, how do we prevent corrosion of steel in these structures where we use them?
We are not come to that stage right now. It's quite a long topic to discuss. When we reach to that stage, if agar ye syllabus mein hai, then we'll study about that. I can just tell you briefly that you can prevent the corrosion by just embedding the steel within the concrete properly by giving a proper cover. But then there are epoxy paints that you can apply. You can apply tar coating over the steels, and then you also check the environmental exposure. It's a long topic. Now, coming to the retarding admixture, this is the second type of admixture.
Excuse me, sir.
Yes.
Huh? So what would be the lowest temperature this accelerating admixture could help in?
The lowest temperature it could help with. Yes, it's around 2 degrees Celsius, which I told you last time. But below freezing point, that is 0 degrees Celsius, it decreases the freezing point of the concrete by 2 degrees Celsius. So you can use it up till, because we don't want to use it below 0 degrees Celsius. So you can actually use it only up till, we don't want to use it below 2 degrees Celsius. So you can only, because it's decreasing the freezing point by 2 degrees Celsius at, मेरे कहने का ये मतलब है, it's being used till 2 degrees Celsius. 0 degrees Celsius is the freezing point of water. Now this is decreasing the freezing point by 2 degrees. So you can use it up till 0 degrees Celsius. Once you are mixing admixture, it delays the setting of the cement paste. It delays the setting of the cement paste. Now, there are situations where we want to delay the setting of the cement paste, which are actually temperature based conditions. For example, you have a very hot weather. Now, in a very hot weather, if there is setting happening quickly in presence of water, what will happen when you have setting happening quickly in presence of water? Because the temperature is very hot, some amount of water must be evaporating at the same time. So there will not be enough water available for under such conditions, and you do not want it to set quickly in such conditions where some percentage of water has evaporated while you are casting the. So what is then happening, that the concrete that you are getting will develop certain voids in between. There will be particles which will remain unhydrated. There will be certain particles yahan se evaporate water karke, so just some particles will remain unhydrated. So you want the setting time to be delayed in certain such conditions, such that you keep on adding water onto the. You are actually adding water. The setting time is actually should be delayed in such hot weather conditions. you do not want it to remain unhydrated. So greater than 50 degrees Celsius temperatures, which are prevalent in certain situations, you want such retarders. Now, when you are using retarders, the retarding chemicals, you are actually hardening is also delayed. This is opposite of the accelerating admixture. So here the hardening is delayed. The concreting that is done now what are the admixtures that are available for retarding? Sugar is one admixture you can use. There are carbohydrate based admixtures, and these are carbohydrate derivatives. These are naturally occurring materials. Soluble zinc salts. Then you have soluble methanol. Methanol is also there. So, and you have now these retarders. Methanol is not an organic, so it's a chemical derivative, an alcoholic product. Then you have now what do the retarders do? What is the process of their action? They actually reduce the water reducing. They are also known as water reducing admixtures. They are actually reducing the amount of water that is required for the setting of cement. So, but at the same time, they are increasing they are reducing the amount of water that's required for the setting of the cement. But at the same time, because it's an evaporating condition, there is less water already available in such situations. So the setting is then getting delayed, as well as then the strength and the hardening development is getting delayed at the same time. So ये process ऐसे है कि आप पानी available नहीं है because it's a hot weather condition, और retarder को पानी भी जरूरत नहीं होता है. The water it is and aiding in such a process कि water की कम water में ही इसमें hydration processes धीरे धीरे होती रहे. So it's actually reducing the amount of water that you actually require for setting of such. So over a long period, not 10 hours, it can go up to 20 hours. This setting process, the final setting time, which was 10 hours, then that could be even going up to 20 hours, even up to 24 hours. But there are certain phenomena which are like plastic shrinkage is one. So once you are adding the sugar and carbohydrate derivatives and zinc salts, plastic shrinkage is happening at the same time. The plastic shrinkage is happening in certain parts of the so plastic shrinkage is shrinkage happening in certain parts of the concrete. Then you have what is the effect on strength development. Now, strength development is inhibited by till 7 days. So, in a normal process, you will get 3 दिन में आपको strength around 80%, 70 to 80% you will be there. But here, the plastic due to plastic shrinkage, sorry, due to using the retarders,